Welcome, ladies and gentlemen, to our last video for our conics unit. So today we're going to talk about hyperbolas. I would highly recommend that you guys pause the video right now and read the definition of your hyperbola and familiarize yourself with all the different parts of a hyperbola. And then when you're ready, you can rejoin me and we will talk about the difference between ellipses and hyperbolas. So now that you're familiarized with what a hyperbola is and all the different parts of it, there's one major difference between the formula for an ellipse and the formula for a hyperbola, and that's the difference between whether you are adding or subtracting. So that hyperbola is you're going to see a difference in your formula as opposed to a sum. Now, just like with our ellipses and our parabolas, we talked about when they were centered at the origin versus when they were centered someplace else on the plane. So as you can see, this chart talks about the different, both equations, whether it is located along the x-axis versus the y-axis. As you can see, because this is just x squared and y squared, this is centered at the origin. So if your equation starts with an x squared, or as we talk about, if it's not centered at the origin, whether it would be x minus h squared, that's going to mean that that parabola is going to open left or right, versus starting with, sorry, left and right, versus starting with a y squared or a y minus k squared value, that's going to open up and down with your hyperbola. As we take a look at the next chart, that familiarize yourself with the fact that these are not centered at the origin. Notice you have the x minus h, the y minus k, giving us a center someplace other than the origin. Now, I want you to take a look at the pictures at the bottom here of these graphs. The green lines, the asymptotes, and the blue rectangles, what you have to know is that those are graphing aids. I can ask you the equation, and I will ask you the equations for the asymptotes. So you're going to have to remember, how do you write the equation of a line given just a point, which would be your center, and then the slope of your line. Okay, so that's something else that we're going to have to pull out of the memory bank. So when you're graphing a hyperbola, you need that rectangle and you need those asymptotes, you need your vertices. All of those pieces put together are going to help you determine whereabouts to place your hyperbola when you're graphing it. So let's actually take a look at graphing one of our hyperbolas. So the first example here says that we're going to find the foci and the vertices of the hyperbola. Now, as I'm finding the foci and the vertices, I'm going to go ahead and go through and show you how to graph a hyperbola as well. So the fact that our hyperbola starts with an x squared, this tells us that this is going to open left and right. Okay, so the branches of our hyperbola are opening to the left and to the right. Because this is an x squared and a y squared, this is centered at the origin. So if you want, you can go ahead and plot that point right there at the origin. That's going to be your center. Now, this wants to know the foci and the vertices. The vertices, we can go ahead and take a look at our a value. So remember, in a hyperbola, your a squared value and b squared value stay put. It's the x and the y that are interchangeable. So when we look at the 9, that's going to be your a squared value, giving you an a value of 3. Now we know that this opens left or right, so I'm going to go 3 units to the right and 3 units to the left. Now those are your vertices. So we can go ahead and write down the coordinates for those. So we're looking at 3, 0 and negative 3, 0. Now, I'm not going to get to the foci quite yet. Okay, I want to draw my rectangle and show you how to graph this first, and then we'll go back and locate the foci values. So in the going back up into the equation, your b squared value is 4, making a b value of 2. This is going to be what's sometimes called your covertices. So because the hyperbola opens left and right, your vertices are on the x-axis. Your covertices in this case are going to be on the y-axis. So your co-vertices are going to be at 0, 2, and 0, -2. Now, together, those 4 points are what's going to form your rectangle. So you can go ahead and box in that rectangle. Remember, this is just a graphing aid, so you're going to draw that in. Now, the asymptotes basically go from corner to corner of your rectangle. So you're just going to draw your asymptotes right through the corners of your rectangle through the center there. So now what we've done is we've set up this rectangle, we've set up these asymptotes. We can go ahead and sketch in our hyperbola. So we said it opened left and right. So you basically start at those vertices and then you follow the asymptotes. That basically gives you an idea of how wide your parabola is. So there, voila, we're done. Okay, so that hyperbola is graphed. So again, locate your vertices, use your co-vertices, draw in your rectangle, draw in your asymptotes, use your vertices to draw your hyperbola. Now the next part of this question though wanted us to find the foci. Now when we find the foci for a hyperbola, again, you're going to go to that c² value. But with a hyperbola, c² is a² plus b². Sound familiar? It should. Good old Pythagorean theorem. All right, so in this case, our c² value is going to be 9 plus 4, which is going to give us a c² value of 13, which means we have a c value of the square root of 13. Now, square root of 13 is approximately probably about 3.5-ish. So if we were to plot the foci values, you would just go out 3.5. So it would be just past your vertice values. But if I want to actually give the coordinates of my foci, I need to make sure that I am using that exact value of the square root of 13. So from your center, think about where did we go to get to the focus points? We went a value of the square root of 13. So I went radical 13 comma 0, and I went negative radical 13 comma 0. So you want to make sure that you're using those exact values. Now the other thing that I want to take a look at is the equations of the asymptotes. These ones are nice because they're centered at the origin, so it makes it a little bit easier to find the equations. So if you'll take a look, we're just going to take a look and find out what the slope is. So the slope of our asymptotes is either going to be a positive 2/3 or it's going to be a negative 2/3. So I didn't really quite need the x on there yet. If I write the equation, it would just be plus or minus 2/3 x. Because again, your y-intercept is 0 there. Okay, all right, let's prep for the next question then. Okay, and the next one it says find the vertices and the foci of the hyperbola y² over 16 minus x² over 20 equals 1. So because this one starts with y², this one's going to open up and down versus the last one that opened left and right. Okay, again, because it's y² and x², it's centered at the origin. So our a² value is 16, which makes a equal to 4. So it's opening up and down. I'm going to go up 4 units and down 4 units, giving me coordinates for my vertices at 0, 4, and 0, -4. Okay, now we're going to go ahead and graph this one, and then we'll go back and locate the foci points. So in this case, when you're taking a look at drawing in your rectangle, your b² value is 20. Not a nice perfect square, but if you were to simplify that into 2 square roots of 5, okay, it's going to be around 4 point something. So I would go left and right a little more than 4. So if we go ahead and draw in our rectangle, okay, you're going to notice that we're kind of not completely exact here because we have an estimated value for our b value, but that's okay. All right, you can go ahead and I didn't plot my center, but it's at 0, 0. You can go ahead and draw in your asymptotes. I know I didn't leave you a lot of room on this graph. This hyperbola is very spacious. All right, so to draw this one in, we said that it opened up and down. So you're going to go from your vertex and open up. And you're going to go from your vertex and open down. Okay, so we've got that all graphed. So that looks like a nice, pretty parabola or hyperbola there. We want to go back in and find the foci values now. Remember, we use a squared plus b squared in order to find our c squared value. So in this case, c squared is equal to 20 plus 16, 36. Oh, this will be nice. We have a c value of 6. So in this case, our foci values are going to be nice integer values. We're looking at 0, negative 6, and 0, 6. Okay, and again, if you were going to go to write the equation of these asymptotes, these ones aren't exactly easy to work with because of the fact that your b value was 2 square roots of 5. So you might have to do a little more calculating when it comes to finding the slope of your line. So this one would be a little bit more involved in finding the equation of your asymptotes. So one of the things that you have to know how to do is you have to be able to write the equation of a hyperbola, given certain specific pieces of information. So this one says find the standard form of the equation whose vertices are located at 0, negative 4, and 0, 4, and whose foci are located at 0, negative 5, and 0, 5. One of the keys to conics, again, is graphing. So what I'm going to do to help me identify which direction this is opening, I'm just going to go ahead and graph this, or plot these points. So 0, negative 4, 0, 4, 0, negative 5, and 0, 5. So if I know that my vertices are located on the x-axis, I know that this hyperbola is going to open up and down. And if I go halfway in between my vertice values, I notice that my center is at the origin. So when you're taking a look and writing the equation, if this is going to open up and down, I'm going to start with a y squared value. Remember, hyperbolas are subtracted. So it's going to be x squared over b squared equals 1. So my a squared value, that's going to be the distance between my center and my first vertices there, which is a distance of 4. So if a is 4, because this is your a value, a squared is going to be what? Good, 16. Okay, and then now we don't have a b squared value. What we have is a c value. So in this case, we have a c value of 5. Well, remember, in a hyperbola, c squared equals a squared plus b squared. So we got 25 equals 16 plus b squared. So when you go and figure out the value of your b squared, you end up with 9. So this is going to be 9 equals 1. And that's the equation in standard form. Okay, now if you wanted to go from standard to general, remember general has to be equal to 0 and you wouldn't have any denominators. So you'd have to multiply through, get rid of your denominators, set it equal to 0, and then that would be in general form. All right, what do you notice about the next one? Okay, well, what you should notice is the fact that it's not centered at the origin anymore. Where is this hyperbola centered? Okay, good. We have a center of negative 2, 3. Did I catch anybody? Did anybody write 3, negative 2, or did you answer 3, negative 2? So make sure that you're paying attention to where your h and k values are. Remember, h is always associated with x and k is always associated with y. So just, you really have to watch those, especially with hyperbolas. Okay, now we have an a squared value of 1, making a equal to 1, and a b squared value of 4, making b equal to 2. So I'm going to go ahead and plot my center, which is at negative 2, 3. Because this is starting with a y minus 3, which direction is that going to open? Good, up and down. Okay, so because it opens up and down, when I go to do my A value, I'm only going up 1 unit and down 1 unit. And then I'm going to go to the left 2 and to the right 2 for my center. So I have a pretty small rectangle that I'm working with. And then I'm going to draw in my asymptotes. Okay, and because we have our rectangle and our asymptotes, we can go ahead and graph this. We said that it opened up and down. Okay, so we have that all set. Okay, and so basically from here, you wouldn't have to do anything else, okay, because all it did was it said graph the hyperbola. But we're not just going to settle for the basics. We're going to make sure that we understand all the different parts also. So if we were going to go and find the foci, okay, remember this is a squared plus b squared. So we have 1 plus 4. So we have a c squared value of 5, which means we have a c value of the square root of 5. So we're looking at a little over 2. So remember, this is the distance from the center. Your center is no longer at the origin. So when I go and do a distance of 2, I'm looking at down here, and then I go 1 little over 2, so that's up there. Okay, so your foci is a little bit farther away from your vertices there. Now, if I'm going to write the coordinates for my vertices, or sorry, for my foci, okay, the vertices should be pretty easy. In fact, let's go ahead and do that before we get to the foci. So your coordinates for your vertices should be -2, 2, and the other one is going to be -2, 4. Okay, how about covertices? Remember that's involves your b value there. So we're looking at -4, 3 and 0, 3. Okay, so there's your vertices, your covertices. Now let's go ahead and work with the c value of the square root of 5. Remember, that's the distance from your center. So when you're looking at your center not being at the origin anymore, you kind of have to stop and think about this for a little bit, for a minute. So your center's at -2, 3. So when I go to write the coordinates for my foci, I want to make sure that I keep in mind that I'm working from the center. So it should be at -2, comma 4 plus the square root of 5. Okay, so back over here at your center, you'd be going -2, and then you would have to go, I'm sorry, it should be 3 plus the square root of 5. Anybody catch that mistake on my part there? I went from the vertices and not the center. So your center, you're going from the square root of 5 from 3. So it should be 3 plus the square root of 5. And then the other one you're going to be looking at, it's going to be -2, comma, remember you're going from the center, so you're going to be 3 minus the square root of 5. Okay, so remember you're always working from the center there when you're locating your foci points. All right, let's talk about asymptotes. Okay, so when you're looking at your asymptotes here, use the center as a point and then use your slope. It doesn't have to be in any specific form. It doesn't have to be point slope. It doesn't have to be slope intercept. So you're looking at a point of -2, 3. So if I was going to write the equation of a line going through the point -2, 3 with a slope of 1/2, I would say y minus 3 equals 1/2 times x plus 2. Okay, and then that's going to give you the positive slope one. So if you wanted to, you could just say y minus 3 equals -1/2. If you wanted to write it as plus or minus, I would accept that. That would be acceptable. All right, last question. Thanks for hanging in there with me. This is the most difficult, or I should say most complex conic, so there is a little bit more to it on a hyperbola. So I appreciate the fact that you have hung in with me through this video. So the last one says we're going to graph the hyperbola. This is given in general form. So the first thing that we've got to do is we've got to put this into standard form. So what I want you to do right now is I want you to go ahead and pause your video, and I want you to complete the square twice, once with your x's, once with your y's. And when you're done with that and you've completed the square, you can go ahead and replay or play your video and check to see if you completed the square correctly. All right, so after you factor out your a value, you complete the square, you should be at a point, or if not further, 9 times the quantity x minus 1 squared minus 16 times the quantity y plus 1 squared equals 144. Okay, so you should have at least gotten to this point. Now, in order to get to the next step, in order to put it into standard form, it has to be equal to 1. So now we're going to go through and we're going to divide everything by 144. So see if you can go ahead, divide everything, reduce, and come up with a final standard form answer. Okay, so your final standard form answer should look like that on the bottom that I have written. Okay, and the next thing that we're going to do is I want you to go ahead and graph this one on your own. Okay, so go ahead and pause the video, determine which direction it's going to open, find your vertices, find your co-vertices, draw in your rectangle, draw in your asymptotes, and go ahead and graph your hyperbola. And then when you're ready, you can replay the video. All right, I am assuming that everybody has a nice, beautiful hyperbola drawn at this point. Okay, so the next thing I want you to go and take a look at is, so everything should be graphed the way that I have here. Okay, and the next thing I want you to do is I want you to write me the equation of the asymptotes. Be careful, you're not centered at the origin anymore. So go ahead, pause the video, write the equation of your asymptotes. So if you like to be efficient and you only want to write one equation that encompasses both asymptotes, you could have written y plus 1 equals plus or minus 3/4 times the quantity x minus 1. Okay, and that would cover both equations for your asymptotes. Okay, so your vertices, anybody happen to figure out what the foci values were? If you did, they happen to be at 6, -1, and you should have another one at -4. Whoops, I plotted that wrong. I went -6. Let's not do that. It should be at -4, -1. That's better. And 6, 1. Oh yes, that looks much better. Okay, so there's your foci values. So you would just have to be able to, if I asked you what the foci values are, remember in a hyperbola, c squared equals a squared plus b squared. All right, you have hung in with me for now 22 minutes, probably over 22 because we paused, did some work on our own. So I appreciate that. I thank you. You can go ahead and complete your Math Excel assignment now. And you, at this point, you should be make sure you're starting your review for your test, which is, oh, check your calendar because I think you guys are on different days. All right, have a great morning, afternoon, evening, depending on what time you're watching this video. Thanks, guys.